Thank you. Good morning. Appreciate you all coming back again for the third round through this issue. So let me remind you of what we're doing in a big picture here. So we, as part of this part of the project, we're developing our ground motion models for a reference rock site condition. That site condition is a shear wave velocity of 760 meters per second. An average kappa value between 0.035 and 0.045 seconds, representative of California data, so that's near the center of our model. And we'll be developing single station sigma and single path sigma models for application. So while this is a reference site condition, this is not intended to match the site condition at either of the two power plants, and that will be captured in the site response evaluation. So those aren't part of SWIS, but are addressed independently by each utility, as Corolla mentioned. But we do have to keep track of the interface, how these things fit together. In particular, we need some specific guidelines on how to implement the site response so that it's consistent with the assumptions and models that we've built up for the rock input motion. One is adjusting the reference motion to the site-specific rock input conditions. So it may be a higher shear wave velocity at, is representative of rock motion. So we correct for that. If there's a difference in kappa, that would also be corrected at that time. And then in particular, epistemic uncertainties that have to be included in the site response because we took them out of our rock ground motion. Okay, so in particular, we're doing single station sigma. You get a reduced variability, aleatory term, but the penalty for that is you need to capture your uncertainty in the median site response. Okay, so there's nothing for free here. You have to put it somewhere. The other part is the kappa uncertainty, controlling, for example, the 10 hertz bump in tau that we talked about quite a bit at the last workshop. We're going to be likely smoothing through that 10 hertz bump in tau. That means that needs to be incorporated into the site response in terms of the uncertainty in kappa. So that has to be there if we're going to take it out of the ground motion model. So this is all about consistency, so these two parts will all fit together. For this workshop, Corolla mentioned this, but I'll summarize again. We're going to describe key data, models, and methods that have been pulled together in terms of responding to some of our tasks. We're going to talk about our proposed approach for the logic trees and give you the structure. And our goal is to get hazard feedback and feedback from our PPRP and our resource experts to influence that approach, make corrections at that time, and then we'll move forward for assigning the weights. So we'll give you the structure of the logic tree and our approach to getting the weights, and we'll be getting our feedback at that time. So I'm going to go through where we are on data needs tasks that were identified either from workshop 2 that were either left over from workshop 1 that we hadn't completed, or that were added at following or during workshop 2. And there are 9 basic categories here. Ground motion data, all the tasks have been completed. That work has primarily been done through peer, so we have been, this project has had a part that we're doing the work and then part that we have sponsored through universities, both at peer and at the Southern California Earthquake Center. So peer has handled the collection and compiling and evaluation of all of the ground motion data. That data are now publicly available on the peer website, so you can get all that. Finite fault simulations have been done using the broadband platform at SCEC, and so we've been working with them over the past few years on that. There are 2 tasks that are still in progress on the ground simulations, and I'll go through the details as we in a bit on each one of these. Dynamic rupture models, we've gone through one set of evaluations of that. Directivity still has 1 task in progress. Our candidate ground motion models, most of those evaluations are complete, except for 1. kappa is the place where there is more left undone right now. We are still, there's still some studies going on in Kappa, particularly for Arizona, as we have been collecting the data and are now having time to do the detailed analyses. Path effects, we'll run through what those are, and one outstanding task. Single station sigma still has some pieces to go to it as we're developing the models. And the visualization for epistemic uncertainty, that's the ducks that you saw last time, if you remember the maps of the ducks and as they rotated around. Nico has been working on that for us, and we have made great progress, and I'm ready to say I think we know how to use it right now. So that's part of what you'll see this afternoon. So I'm not going to read all these to you, but the ground motion data tasks are all available. Again, all of these were evaluated or done working with peer. The one places that were done outside of peer was Task 1C, looking at the ground motion from Wells, Nevada. That was just an evaluation of the peak velocities. That's been done. The other part is we had looked at trying to do, one topic was source inversions for Japanese earthquakes that would help us with hanging wall scaling. We found in Task 1D, which we'll show you later today, there really is no good data, even with all the Japanese data, close to magnitude 5.5 to 6.5 earthquakes, particularly smaller earthquakes, for hanging wall effects. So we tried to find candidates, and there weren't there. Okay, and finally, data in Arizona from Kukapa at the VA hospital was nothing usable was recorded. Finite fault simulations. We've been doing our simulations for complex and splay ruptures. I'll talk a bit about the complex rupture later this morning, and splay ruptures will be discussed. Results will be discussed today. Oversaturation still is an issue for us, and we're going to be talking about that at the workshop today. And this is an area where, if we find out we could really use some additional large magnitude scaling to help us, we could do some additional simulations. The hanging wall effects and simulations have been completed. In addition, this is more finite fault simulation tasks. We've been looking at, comments came up from Tom Heaton looking at the slip distribution and how the slip compares to the peak and static displacements. That work has been done. We've been looking at, we had the X-sim proponent model discussed. And then do we want to do additional simulations for magnitude 6.5 to 7 buried ruptures? None of those were done previously, and we're looking at running those in April. Rupture directivity models. So, and dynamic rupture models. So one is using the dynamic rupture models to constrain the source properties for splay faulting. We think that's going to be helpful for the source characterization part, but the dynamic ruptures aren't ready for us to take their ground motions yet and start to apply them. So that is one of the tasks that's moving forward, but it's probably it'll be in future studies that we get to that state. For directivity, we have a model now for directivity that can be incorporated into our GMPEs, so that's a big step forward. This is, again, from peer studies, and will be summarized in a set of peer reports. And then the piece that is still pending is evaluating the uncertainty in that directivity adjustment. For us, I said pending, depending on hazard feedback. If this is a significant contributor to hazard, we need to have the uncertainty in that term. If it's a small contributor to uncertainty, then we'll just use a single model and go forward. The candidate GMP task. So we had pieces that had not been done previously. The Idris model has now been presented and discussed with Idris. The evaluation of the upper tail of his distribution was discussed, and we're going to have to develop, I should say, we evaluated that, but the model is not yet complete, so that should have a final model to be built. We had a whole set of outstanding issues with the GMPE developers that were identified at Workshop 2. Bob Youngs will run through all of that for you after me and that suite of responses. Issues we still have about the magnitude scaling, such lack of magnitude scaling above magnitude 7.1 proposed by Zhao. Do we see that in other data sets? That's still something that's going on and we'll be discussing. Substituting Bindi with his updated model, that's done, and evaluating the distance attenuation from Arizona is done as well. Kappa tasks, again, have some parts. We've identified key stations for Arizona and had site characterization done for them. Kappa, the acceleration spectra, and Kappa from the displacement spectra have been completed, work done by Olga. Kappa for the using the broadband method, is a peer study that's still in progress. There's a peer report that's describing all of the Arizona data. There's a draft complete, and by April, the peer report will be published on the peer website. We were looking at reviewing using blast data for Arizona for Kappa. We've decided that that's really we're not going to do that. We don't see that that will be helpful for us at this time. Developing Kappa estimates for small earthquakes from Diablo Canyon, that's a part that is still in progress. We have those data are all available, and you saw some of that at Workshop 1, but we have not completed that work. And then we evaluate the need for adjusting for Kappa for foreign GMPEs. Are there Kappas in that range, 35 to 45 milliseconds or not? And that work is done. The bottom line is those models all have similar Kappa values, so we don't need to adjust them to our reference rock case. Path effects is now really getting into what do we do, any region or source-specific adjustments to the GMPEs for their path effects. Part of this issue was in the numerical simulations, what velocity model do we look at? Those have been evaluated. We have, from that, decided to use the reference velocity model being used at SCEC for Northern California, and that's been done in the simulation. However, this information from the velocity structure at Diablo Canyon, which was compiled as part of the source characterization, will be used for the analytical calculations of site response. Then we had regional ground motion data near Diablo Canyon for path effects. This is in progress, and I'll show the data that's available for that on Wednesday. And then path effects evaluations for Arizona will be showing at this workshop, and that's for the large distant California sources. Single station sigma tasks we've been making some progress. We still need to modify parts of it. This is developing the single station model based on California and NJ West data. Linda Alatek will be talking about that tomorrow. Single station sigma, a single source to region sigma model. So this is like a path-specific model will also be completed and will be shown to you tomorrow. There's a separate issue of potential bias in our sigma values that we get from empirical data due to spatial correlation. That is, stations, when we have a data set, they tend to be, let's say, even if they're a few kilometers apart, those are not independent. So when we just treat them as independent, we may underestimate the bias. So that work is being done right now, updated at Virginia Tech, and that is in progress, and we should have that soon. And then, and so that will be something that would affect all of the standard deviation models. And then the other part is the upper tail of the distribution using a mixture model. So last time we saw evidence for fat tails in the distribution of the within event residuals. And so how do we capture those fat tails? And so that is under development. We have an initial model for putting those together to cover the fat tails. Visualization. So I wrote completed here. I guess that's very bold to say. I believe once you've after the end of 3 days here, I hope you agree with me that we know what we're doing on this part. It is new, but it's really, I think, a powerful framework for us to deal with our fundamental problems of how do we capture uncertainty in multi-parameter distributions like GMPs. So we're going to hear some of that. And then I actually put on here, the last thing is our white paper on the site response rock site interface. That will be written as a paper and included as in part of the hazard report, so that there's key guidelines on how this stuff needs to be used, and, or to be sure the interface issues are properly tied, and all of the pieces of epistemic and aleatory variability are covered and not double counted. Okay, any questions on all of that? We've done a lot of work trying to get all these tasks done.